All right, so we're going to start with the specific heat capacity problems, which you said were numbers 4 through 7. So the good thing about these problems is that they're basically all the same problem. You're just trying to find different things. So if you remember, Professor White talked about on Monday, it was all this formula right here. Q is equal to S times M times delta T, the change in temperature. All right, so Q is the heat. All right, Q is heat. S is the specific heat capacity. M is mass. And T is temperature. So all these questions are asking you to do is to take this formula right here, Q is equal to S times M times the change in temperature, and just solve for whatever they don't give you. Now, there's a few things to remember. The first one is the heat always has to be in joules. In joules, and not kilojoules. Sometimes the problem will give you a kilojoule, and if they give you a kilojoule, that means you have to change it into joules before you start working on the problem. All right, same with mass. Mass always has to be in grams, not kilograms. If it gives you kilograms, you first have to convert it to grams and then solve. All right, so number 4 here, it says, at least for me, how much energy is required to raise the temperature of 13.3 grams of solid tin from 20 degrees Celsius to 37.1 degrees Celsius? All right. So first, we got to look at what it gives us. That way we know what it wants. So it says we have 13.3 grams. So that's our mass right there. It says we have 20 degrees Celsius to 37. So we start at 20, and then we end at 37.1 degrees Celsius. So that means the difference in temperature, the change, is just 37 minus 20, which would just be 17.1. All right, so now we have our temperature. And then the last thing we need is either going to be heat or it's going to be specific heat. Now, it doesn't tell us whether or not we're given heat or specific heat, so we kind of have to do a little reading between the lines. If you look back at the question, it says 13.3 grams of solid tin. All right, now that's the thing we have to notice. It gives us the material, and now that we know the material, we're able to find out the specific heat. So what you're going to want to do is you're going to want to go to this tab right here that says References, and you're going to go to General Chemistry Tables. It's going to open up, and then you're going to go to Specific Heats right here. And since it told us that the one we're looking for is tin, we're going to find tin. There it is right here, tin. All right. See right here, tin says it is 0.213. So that's the last part we need in our equation. It doesn't give us Q, but it does give us S, which we just looked on our chart, and it says it's 0.213. All right, times our mass, which is 13.3, times our temperature, which is 17.1. All right, so you just multiply all these together, and you get Q to equal 48.4 joules. All right, so that's it for number 4. And then numbers 5, 6, and 7 are all the exact same thing, but they're just asking for something different. So maybe it'll give you everything except for temperature, or maybe it'll give you everything except for the specific heat capacity. And all you have to do is the same exact thing. You just got to solve and then plug and chug, and then you get the final answer. The only thing that could be tricky are the ones for temperature. After doing the equation, I'll give you an example. Say it gave us 45 as the heat. It gave us lead again, or tin again, which would be 0.213 for the specific heat, and it gave us the mass in grams, but it didn't give us the temperature. All right, so solving for this, we get 45 divided by 0.213 times 13.3 is equal to the change in temperature. All right, I'm just going to do that math real quick on this calculator. All right, so it tells us that the change in temperature is going to be approximately 15.9 degrees Celsius. But, this 15.9 degrees Celsius right here, this is not your final answer. If you put this in the box, it's going to be wrong because this is just the change in temperature. Oftentimes, the question is going to ask, what is the final temperature or what is the initial temperature? For example, I'm looking at number 5 right now. Right after number 4, it says, a sample of solid tin is heated with electrical coil. If 48.4 joules of energy are added to the 13.3 grams at initially 20.0 degrees Celsius, what is the final temperature of the tin? All right, so just like this example problem we just did, it gave us the heat. It told us it was tin, so that way we know what the specific heat is. It gave us the grams, but it didn't give us the temperature. So when we worked it out, we found the temperature, but it's asking for the final temperature, not the change in temperature. So we would take the initial temperature, which it says it's 20 degrees, and then we would add the change in temperature to get our final temperature, which would be 35.9 degrees Celsius. And this would be the answer you put in. All right, now this isn't going to be the answer for the question that I just showed you because I used different numbers in this example problem. But make sure you pay attention to whether it's asking for the change in temperature, in which case you can just put this. Or if it says something like the final temperature, you have to take the first one it gives you and then add this one. Or it could even say something like the initial temperature, and it could give you the final one, in which case you'd have to subtract this. So if it said, instead of initially 20 degrees Celsius, it said its final temperature was 35.9, for example, then we would take that 35.9 and subtract the change in temperature, which we already found by solving, and we would get the initial temperature, which would be 20 degrees. All right, so I hope that helps for numbers 4, 5, 6, and 7.